Welcome to a new and unique episode of Café, entre, Caminos podcast. I will be your host, Claudio Feijó, Jamon Chair on Tech Diplomacy here at the Technical University of Madrid. And today we have privilege of gathering together for the first time, I think, in history, the three directors of three of the main schools of civil engineering in the world. We will have director of MIT, the director of UPC, Universidad Politécnica de Catalunya, and the director of UPM, Technical University of Madrid together. And they are going to discuss which will be the future of civil engineering education in view of global challenges.
First, thank you, Claudio. Thank you, Esther. Thank you, Ali. It is a pleasure to be with you. I like to say that there is like an Spanish approach to education in civil engineering, I think, and it's shared by most of our schools in civil engineering. We prepare an engineer that is very transversal to civil engineering with strong basic sciences, and it is becoming more and more important to prepare them to understand the impact of the economical parts, of the societal parts of the infrastructure. In that sense, what we are doing is introducing more project management, introducing more risk management, contract management in our curriculum. The key to do that essentially is to establish a deep link with our industrial sector. We need to have a continuous conversation with our industrial sector because they are the ones that are working in this complexity in the day-to-day. And obviously it is becoming a hot topic for us. And the way we try to solve the problem clearly is to attract this industrial sector to our schools and try to combine with them, to try to redefine with them our curriculum.
I see risk. I heard also industry, private players, and I don't know, maybe Esther, Ali, you want to say something else?
Yeah, I think increasingly the way I'd like to think about this is that civil and environmental engineering is becoming a transdisciplinary endeavor that basically throughout its history, civil engineering has involved human decision makers. So there's always a human element to any large infrastructure project. So you have stakeholders, you have governments and regulators, you have preferences. And on top of that, because infrastructure systems are capital intensive, you cannot separate the project or the science and technology and engineering of it from the economics and policy. They go hand to hand. So from the beginning, I believe, this has been already integrated. I would like to say that civil and environmental engineering is the most human of all engineering
that's true.
Disciplines.
Yeah, that's true. That's why sometimes in our curricula we need to introduce also the sensitivity for the students to think about the impact about their decisions, their plannings, and how to influence. So I have a friend of mine that is the CEO of Oxfam Intermon, it's a non-governmental organization, and he always says that we don't decide that when we were born, but or the world we are living in, but we can decide how we can face the situation. And we as civil engineers have superpower. So we need to use this superpower, and we need to convince our students that it's very important that they have the technical skills that you explained, but it's also very important that they are good in maths and analysis and this kind of things, or nonlinear analysis and all these kind of things, but also critical thinking and sensitivity about the impact of at the end of designing these infrastructures, planning, and all these things.
We like to say that we will need resilient infrastructure, but we also need resilient engineers and flexible engineers and sustainable engineers for the future. No? And for that, it's clearly necessary to understand the complexity of our projects nowadays and the impact that they have in society.
Yes, for I think the discipline has recognized for a while that large-scale infrastructure systems are socio-technical by nature, that there's a societal element, there's a social element, then there's a technological element.
Political element also.
Yeah, and a political element. So, and one of the big challenges is how do you integrate all of this in a way to train a well-rounded engineer, but also to have depth. And so this is something that we've been thinking about for a long time as well. And now I think increasingly with the role of data and digital transformation, we know a lot more about preferences. We can measure a lot more and more accurately. And so one of the key challenges for the future is how do we aggregate all this information that we have to do things better?
Yeah.
Please. Now, coming back to one thing that you say at the beginning about that the civil engineering is engineering with more human impact. I must say that when I ask the students why they choose civil engineering studies, at least in my school, some of them, mainly men, say, because I like construction. But most of the female students say that...
Commitment.
Yes, just relation to this more human engineering impact. So I think that it's important that change the mindset of some people or the society here in Barcelona, in Spain, about civil engineering is not construction. Yeah. Not only construction, civil engineering is more than that. It's planning, it's acting for the future, for human, for society. I think this is important.
Yeah. At the same time, I like to talk a lot about our identities. We shouldn't lose our identities, and our identities are probably different, even the ones that between our school. Probably our identity is a common origin coming from what we call Ingeniería de Caminos. It's a very, as I said, a Spanish approach to education in civil engineering. But obviously, this identity is evolving in time. And now there are some things that are added to this identity because civil infrastructure are changing, because the impact of this infrastructure can be seen today in a different way. So this is something that we are improving day to day, even without losing that identity. This is a hard work, okay? And it has to be with our duty as directors of the school, how to change and how to maintain at the same time the identities of our schools.
That's a very tough balance, and there's something that we've also thought about a lot. If you look throughout history, at least in our case, that the history is not as long as yours. We go back to at MIT to 1865, just after the Civil War in the United States, where things started. But if you look at the trajectory of civil engineering, the name has evolved over time. When we started, it was civil and topographical because Boston was becoming a city and, industrial revolution was about to happen. Its Civil War has ended. You need to build. So the first thing you need to do is to map and then to create. Yeah. And then, there was a lot of landfills. Then the next name was civil and sanitation. That's the birth of environmental engineering at MIT. Then later it changed to civil and building because, and then it went back to civil. Then in the last iteration in 1990 was civil and environmental, which was also followed up by others.
What about extreme weather events? What about climate change? What about putting resilience, sustainability into infrastructures and into infrastructure education? To try to tackle climate change and other threats. It's not the only threat, probably.
That's a very good question. In fact, I consider climate change to be the defining challenge of our time. Basically,
the elephant in the room.
Yes, the elephant in the room, exactly. And the biggest challenge is that the formula that we used for human development across 20th century no longer works. if you think of this game in a game theoretic sense between the built environment and the natural environment, right now we're off equilibrium. There's, in 20th century, we created this amazing industrial civilization, but at the expense of the natural world, so in an extractive way. And that formula no longer works because we're running out of time with climate change. Yes, you may argue, is it going to be 1.5 degrees, 2 degrees, 1.2 degrees? But we know climate change is happening. We already are seeing ramifications of it. It's affecting our critical infrastructure. And, it's already priced into insurance models. You see the effects of it, whether it's mudslides in Spain or these
in
extreme fires in California last week, and in fact still ongoing. We need a new way, and the new way is that we need to bring these Earth system constraints into the design from the beginning, which emphasizes the way that we have to do the training, because those environmental constraints can no longer be an ex post consideration. They have to be included at the time of the design. And I think we need this. This is why it takes a village. You need to have people with different skills to work together. Yeah. And we need to change the way we train scientists and engineers in this space that is sort of informed by, in a way that, based on traditional disciplines, maybe didn't need it as much.
We in Barcelona, I think about 8 years ago, we had different departments. You know that here in Spain, or this in the UPC, we have schools and departments. And we mix all the departments in one department that's called Department of Civil and Environmental Engineering. So the school is still having the name of Caminos, Canales y Puertos, but the department. And we create also one degree, that environmental engineering degree, that it's not civil engineering, but they work more or less together. And it has been important for the school and for all the people just to start really thinking about what environmental engineering means when we talk with, or in the civil engineering ecosystem. And I think this is important, just not thinking as a human-centered mindset, just putting people or humans out of the box, and having more environmental ecosystems or nature ecosystems, and this is important, but this is not easy.
Yes, very much.
I completely agree. I would like to emphasize the role of civil engineering in all of this, because I think we are like the soldiers at the front against the violent effects of climate change. So probably we are the people that should be concerned about trying to stop things when things are out of control in that sense, because all of our infrastructures have been designed, constructed, and their maintenance. I think we have implicitly the assumption that they are designed for an unstable climate, and this is not happening anymore, probably, or at least in the next years. And we should. This is affecting our infrastructures too, and they are more vulnerable, but at the same time they are more necessary than ever. And this is something that we need to introduce in our curriculum. Probably we should talk about resilient infrastructure, about safety coefficient. Yeah. But there are some things that we don't know, and at least we should be honest and say we cannot go on doing things the way they do, because the climate is not the same. So it's not as stable, at least.
We need to prepare our students to face problems that they are still not here. Mm-hmm. So we cannot imagine, no. So it's like, so how you prepare them to be solvers for the future? when we don't know about which problems are coming.
Yes, that's very much so. But I think we do know that, you know, climate and sustainability are, you know, important challenges of our time. We have sort of pivoted our department towards what I would like to call, you know, achieving sustainability across scales, where we use sciences from the nanoscale to the global scale to think about, you know, how do we use microscopic measurements to understand how we can decarbonize the process of making cement. You know, concrete is the building block of modern civilization and every infrastructure. It's also responsible for 8% of global carbon emissions.
Yes.
And
so we are part of the problem also.
right, exactly. And so the question is, you know, at the same time, you know, we want growth to continue, right? So we want to bring people out of poverty. So everybody wants a house and a roof. And so the question is, but we can't repeat that process we went through. So what we're looking at is what are some of the ways that, you know, we have to decarbonize you know, the process of manufacturing cement. You know, if we want to hit basically the goals of the Paris Accord, we have to, you know, concrete has to be carbon neutral, and that's a massive challenge. You could say the same thing about steel. You know, how do we decarbonize concrete, decarbonize steel, decarbonize manufacturing of chemicals, decarbonize textile, you know, decarbonizing energy and transportation and agriculture. None of the goals that we've set can be achieved without, you know, a massive effort in decarbonization. And even though there's one word, decarbonization, but in each of the things I mentioned, requires very different tools, methods, and technologies.
Yeah, but this needs a very important political agreement. And probably I'm saying things that
because things are expensive.
But if they put the political decisions, because at the end, now we are doing some research on reuse, steel reusability, but a reused steel is more expensive than a new steel.
Yes.
So we still don't have which are the maximum values of emissions, CO2 emissions that we can have in some different aspects. We know how to measure, but we don't know which are the maximum values. So these limits should be agreement politically. And I don't know if all the countries or all the politicians in the same country agree with this. So I think it's where we need to push as institutions, as leading institutions, to this way, probably. I don't know.
So how to address that from the perspective of education and research? This infrastructure reaching the end of their lives.
So it's true that most of our plans, the study plans, are thought for designing new structures or new infrastructures. And even the structural codes, for example, I'm on the structural design part, but all the codes, or most of the codes, are focused on how to create new structures, steel, concrete. But now we cannot continue that way. We need to know how to use more efficiently, or how to retrofit the structures we have, how to or compare it's better retrofitting or just demolition and construction now. I think Europe, probably also the States, and also in China, because we had a conference in China before Christmas, people are start thinking on that. Now we have the opportunity with this digitalization of infrastructures, so we can measure how is the health of the infrastructure. We need to know how to measure and what to measure, not to have a lot of data that we don't know what to do with that, and how to use this data efficiently, probably with the artificial intelligence or some machine learning. So I think that now we have the problem, that's the problem of the climate change and that we need to decarbonize, but we also have the tools that are the tools related to the digitalization and structural health monitoring. And I think that combining all these things, we can make a big advance on this direction. But we need to, I think some of us are quite convinced, but now we need to put it in the curricula of our studies, and also push the professors. But as I think the research system helps us, because research system only puts money. This is why governments, for example, help us, because they put money if you put research on this way. So I think it's interesting.
Yeah, I think more and more digitalization, maintenance, and monitoring are becoming part of our curriculum. But I would like to emphasize also that we need to transmit to the society, and even obviously to our students, the value of infrastructure. I think it is very easy to forget the things that we use every day. And we need to tell society that infrastructure is not a given. This is an achievement, and what it is more important probably is that it's one of the few things that are clearly collectively achieved. Because obviously the engineers are important to build, to design, but infrastructure is collective. It's collective, from that point of view, they represent the commitment of the society with ourselves. And so if we are failing in maintaining our infrastructure, we are failing in our commitment as a society. They say money gives freedom to individual, but infrastructure gives freedom to all the people. And in that sense, it's quite important to transmit the heritage of our infrastructure to the people, to our students. We have a beautiful project in which our students serve as guide on the weekends to show the bridges of Madrid, to show the railway stations of Madrid, and to understand the infrastructure, even the water suppliers and these kind of things. So in that sense, it's quite important to transmit the value of infrastructure, because maintenance of that value, maintenance of that heritage, it's a clear vision of the commitment of our society.
That's very true. One of the challenges, and this is something I work on myself, making rational collective decisions is hard, and that's what infrastructure investment, decision-making processes are always messy and hard, and you often have the NIMBYism, not in my backyard. Everybody wants the benefit, nobody wants to pay for the cost. Everybody thinks the other person is going to pay for it. So these are some of the typical challenges, and these are well-known issues in economics. Public good games are very well studied, and infrastructure investment is an example of a public good game where because everyone thinks the other person pays. Unless a good mechanism is designed, the outcome is not desirable. So this is where the rules of the game have to be such that the desired outcome is achieved with the right incentives. So to that end, I think we're going through this crisis in the Western world, and actually even in the developing world, that basically, we're running out of housing. Housing is expensive. We don't build fast enough. And so the question is, one of the interesting questions is, this digital transformation, how is it going to help? Yeah. Right? And is it going to help? To what extent? What is going to be the role of artificial intelligence in the coming years in adding more efficiency? As we were discussing earlier, all we're seeing out of the role of artificial intelligence here so far is taking some jobs away and putting a huge burden on electricity and water resources. And so the question is, how do we make sure the benefits also get us there? I see a lot of promises for AI, for additive manufacturing, in making, allowing us to do more with less,
Yeah.
right, in more efficient ways.
It seems that I have been reading some papers that now most of the population is moving from countrysides to cities. It happens since the last 200 years, but I read some numbers about what happens in some cities of the States, and it's incredible. And at the end, cities or new cities need to be planned in a good way, but water and energy are the most important resources that new cities or cities for so many people need. So I think this artificial intelligence activities could help in this, creating these new cities or environments. No?
Yeah, to that I want to add the need for, as we mentioned, decarbonization. Food production is yet another example. In
food, water.
Yes, in the next 30 years, the population is going to grow from 8 billion to 10 billion. So that's 25% increase. But it's predicted that our food supply has to increase by 50%, not 25%. And so that requires advances in agriculture. And how do we decarbonize that itself is a major issue, because as we all know, agriculture is a major source.
But let these things to the agricultural engineers, because if not, we will have a problem.
Well, we are using biomaterials for agriculture.
Yeah.
For us is also.
So moving on, since you have started to talk about global issues. So what about geopolitics of infrastructures? So now big important infrastructures, they cross jurisdictions. We need to collaborate. At the same time, maybe we compete even with rivals. There might be even more complicated situations, conflict, war. So maybe we can even talk about something like infrastructure diplomacy or something like that. So I was wondering, maybe José Miguel, you want to say something about this complicated?
Yeah, I like that name, infrastructure diplomacy. Okay. We should try something on that.
So maybe this is the first time ever.
This is the name of a course, of a future course.
Infrastructure diplomacy.
Now, we learned from 2010, from the crisis, that we should prepare our students to work all over the world. And now our companies are working all over the world doing crazy infrastructures, beautiful. It's incredible. It sounds nice, but it is hard, because infrastructures are at the same time a geopolitical tool that is transforming societies, that is transforming the economical growth or something like that. And we cannot forget that we are not in a climate stable, but we are not in a geopolitical stable environment. Things are changing quite a lot. And so what we are trying to do is trying to make our students, that they have the concern of the effects, the implications of doing these jobs all over the world. And introducing subjects like global economy, international contracts, tech diplomacy. We are starting something related with tech diplomacy, because technology now, it's a geopolitical question all over the world. It is a fight about technology. And obviously, infrastructure is a key for societies, and in that sense, it is also a political. Every time that we see a war, there is a destruction of infrastructure. Is one of the first things that is happening clearly when we talk about something like a war.
But the problem is that probably most of the societies are not resilient without infrastructures. So, or we don't have plan B when we don't have this infrastructure. We are really vulnerable to this. So it's like we need to have a, what do you say, a global agreement, or I don't know how to say about that, but or make them more resilient. I remember when we had the COVID problem, and just before the COVID, during the lockdown, the water company in Barcelona, Aguas de Barcelona, was a very important infrastructure, and they moved very fast just to save. It was not a geopolitical problem, but it was a different kind of problem, but it was important. And there are a lot of attacks, so also informatic attacks and this cybersecurity for this infrastructure. Like if you want to make, it's like reading a book about what happens if someone attacks an infrastructure. It seems
I think that one consequence of the digital transformation and the advances of information technology in modern infrastructure systems is that we have now turned our infrastructure into cyber physical entities, and as a result they become vulnerable to attacks. So that's a major issue, because adversarial cyber physical attacks to our critical infrastructure, could have national security implications. It could have dangerous ramifications on all fronts, and this is sort of one of the consequences of this hyperconnectivity that we create. The other side of it is exposure to what I would call a systemic risk, because now we're interconnecting everything.
Yeah.
So we are exposing things that used to be isolated to the risk that comes from other parts. So we're making things more efficient by coupling our infrastructure networks together. But their interdependencies create amplified vulnerabilities and risks.
And there's something that I heard from our moderator the other day, and it was really interesting, is that one lesson learned is that we should be aware of our vulnerabilities, and we should focus on our vulnerabilities, because until now we had tried to look on the other side. But now we should have very clear what our vulnerabilities are, and we should face them and protect them clearly.
Yes. So you need to be planned for that, so to have resilient and robust systems. Otherwise, as Mike Tyson says, everyone has a plan until they're punched in the face.
So from an educational perspective, how to address that from an educational perspective? How to put data, software, AI, you name it, within civil engineering education?
That's a challenge, but we have some tactics, okay? For me, we have developed a master program mostly on executive level. They call the PON. It's a European project to try to develop digital skills for professionals, because now there are plenty of professionals working there, civil engineers, that they don't have the digital skills enough to face some of the problems that they have to face today. So one way is that way. From the point of view of our bachelor and master programs, my vision is that we have very good mathematics subjects. Probably in the future this should be combined with some informatics, programming, artificial intelligence, more statistics. And in our case, we need to improve. I don't know in the case of yours, but we need to increase our statistics in the problem. Data science should appear clearly in the problem, because these digital skills are key for the future, clearly. So different tactics at different levels, but clearly there should be a very visible part of our curriculum that is devoted to digital skills. You don't need to be an informatics, but you need to manage digital skills if you are a civil engineer, obviously.
Yeah, I think it's something similar to what happens when the numerical methods appeared 50 years ago. That we were not experts on informatics, but we became experts on numerical modeling and using this finite element modeling. And now we are learning a lot. Some of our professors are very good on also in our school on artificial intelligence, and also they call like some applied or organic artificial intelligence, and just mixing this knowledge that we have from before and this important good base of mathematics apply this to engineering problems. I think that most of our studies are moving to this way.
I think the three of us are also lucky in the sense that we belong to very strong technical universities with very strong branches of informatics that can help to develop our own human resources for the future. Probably we don't have them right now, but we have the people around that can help us to develop that. It's important.
So at MIT, we've very much done that. We have the New College of Computing, has been around for 5-6 years. It's basically we're infusing computing education into a lot of our disciplines, including civil and environmental engineering and climate systems. And I think it's inevitable that, data and computing have become an integral part of infrastructure systems. They're not just the physical part, but what I would call their sort of infrastructure systems these days are human cyber-physical systems with sort of algorithms on top. So we need a new breed of engineers who can understand the physical world, but they can also understand the cyber and the human and the algorithmic side of this.
But I think that having this, managing this data in a usable way, you need to have knowledge about computing and artificial intelligence and machine learning, but also about civil engineering. That's why mixing both is when you can obtain good solutions for the problems using the data, not only knowing about how to generate the data, but what to do with this data. So you need to apply.
Context matters.
Yeah.
Urban growth, demographics, so there will be new demands, increased demands in cities, changing population dynamics, maybe. So maybe, Ali, you want to say something, because you were mentioning this a little bit beforehand? Yes,
so that's, the challenges are plenty. As I said, we have essentially depleted the planet of a lot of its resources. We're in the middle of another mass extinction of species. The climate change has exacerbated that, and it's no longer a theoretical, hypothetical construct. It's actually happening. So we need to move, and we need to move fast. And this comes on top of this challenges of urbanization, of declining population growth in the developed world, which is sort of a double whammy, because not only you don't have new workforce, but you also have massive obligations through entitlements. So it's a positive feedback that it's self-perpetuating. But then you have this, most of the population growth that is going to happen in Africa. And, but then you also have the climate-related challenges of drought in the Mediterranean region, in Persian Gulf, Southwest Asia, and so and North Africa. And so the question is, what should be the formula for development and what is the right way to think about this climate infrastructure nexus for the remainder of the century.
Yeah.
No, I think that in that way, the climate change, so we are worried about climate change, our northern countries, and we are talking about digitalization, new infrastructures, how to manage and so on, but the climate change really affects the southern countries more than the northern countries. And this is how we can, I don't know, have a global thinking just to also to put our capacities, just not to help them. I don't want to say that North people need to help South people. I don't want to see that I'm saying that, but also thinking in a global way, not thinking also as a northern population. And there are big differences between these parts and how we can work just to prevent these disasters in the southern countries. I don't know. I don't have the answer, but it's something that I'm worried a little bit about.
Yes, what we call, the frontline communities that are affected by climate change. It's sort of this issue where the people who had the least responsibility with the problem are, because of their lifestyles, was less modern, less carbon intensive. Yet they are exposed to most of the vulnerabilities, and I think we're not acting fast enough. There's a lot of good talk and recognition of this problem, but this is one of the reasons that we have launched this climate project at MIT as a presidential priority that we hope that it will have an impact over the next decade. This is our mission, basically, to have a positive impact in the space. And climate is not one thing. It's a confluence of a bunch of things, and decarbonization being a major part of that.
Yeah, I had a different perspective here. We are talking about cities. My tactic as a director of the school is trying to strengthen the link between our school and Madrid. I think the three of us are lucky because we belong, our universities belong to great cities. So my vision is I try to introduce the problems of Madrid as problems of this school. Mm-hmm. And in fact, I always say that probably our school is the institution with a stronger impact on the city. There are no other ones. There are no other ones. Probably that has the same impact because probably in Madrid, the people goes 1-2 times in a life to the Prado Museum, some of them, but every one of them are using the infrastructure systems that we develop, and some of our professors have developed from here. So my vision is we are lucky. We have a great city with very strong problems in terms of infrastructures, and I try to attract these problems to connect these problems with the reality of our students, their final year project. We have a chairs with the mayor or something like that, and try to have like the infrastructure systems of Madrid is part of the identity of our school. This is something that I try to work hard.
We have a very important living lab.
Yeah, that's it. That's it. We need a lot of things to learn and a lot of challenges to focus.
Yeah, but you know that at least I suppose not happens in Boston, in the MIT, but here there was a time that there was a gap between the university and the professional society, and I start doing this, as you say, we agree on that it's putting more the problems together to the university, and we are not making theoretical things, we are working for the society.
So we should be global, but we should be local also, because problems are here.
No, it's also.
Yes. Esther, more on that gap, because I'm interested in this that you have said. What about closing that gap in CO2 emissions? How universities, and in particular civil engineering schools, can help in that? Or is there anything particular that we can do that on that? Or?
to reduce this, to help to reduce
be the leaders,
CO2.
By education, research, you name it.
In our case, I think now we have really in the civil engineering school or in the Department of Civil and Environmental Engineering, because we are more or less 90% the same, we have strong research leaders with very important European and international research projects facing that problem. So I'm happy with that in different fields. So even with urban mobility, for concrete, steel, or also for water. And I think this research is helping the professors to recognize the problem and to transfer to the students this problem. And they are also participating in some local projects just to help or to collaborate with local designers and politicians and to make this a real solution.
So you are bringing also the decision makers, no, to close that gap, no, into this
yes.
project.
I'm going to say something that probably is not a very political correct. No, but one of my big dreams now is that in few years I would like to have more civil engineers in decision-making positions that we don't have now.
Completely
just
agree.
here,
Completely
not more. I'm not going to say more. But it's
agree.
important that we have more civil engineers with high-level knowledge in some important places. For example, a very nice example that we have in Barcelona is the port, the harbor of Barcelona, Port of Barcelona. The CEO, the general director in the last years now is the president, and it's a civil engineer, and also the CEO that they have now is civil engineer, and they have a lot of civil engineers, and how they face the problems, how they are facing the transition, the energy transition, the CO2 emissions, and the environmental impact. It's really nice. It's in a clever way, and you can notice the difference between this infrastructure, that's a very important infrastructure for Barcelona, compared to others. And
the mantra here in the profession is that they don't hear us. Politicians don't hear engineers, but I think we should be there.
Okay.
So we shouldn't be here. We should be there in the.
Not for hospitals or sanitary systems. In the sanitary systems, I want to have a very good doctors, but for our world, I think it's important to have people well prepared in these fields.
At the same time, I would like to emphasize also that obviously MIT is a very important actor in trying to stop emissions, to reduce emissions. But Spain is an important actor too, because we are very good in renewable energies. Yeah. We are very good in civil engineering. We are very good in education and civil engineering. So I think this is a place to talk about CO2 reduction. To reduction of emission, it's a place. It's a place to do. In research, and to have a voice to define the future of this kind of things. Probably we should convince ourselves that, but we should do.
Yeah, whether it's reduction of greenhouse gases, whether it's CO2 or methane, measuring carbon emissions, itself is a big thing. Understanding better the natural cycle of carbon. The terrestrial carbon sink itself is still quite unknown. How human activity and grazing and plant growth can affect that, it's one of the big unknowns that we don't quite know. And it's one of the big uncertainties in climate models is in fact this, that we know how much carbon we put in the air. We know how much carbon goes to the atmosphere. We can measure it. We know how much carbon goes to the ocean. How much carbon gets absorbed in the soil. We know that's net sink for now. How much longer that lasts, we don't know. Part of it is that human activity affects that. the overdevelopment, overgrazing, has affected, how much, what kind of vegetations we have, and that affects itself what the carbon sink is. So there's still a lot of science that needs to be done on that front, and there are a lot of discussions about nature-based solutions in terms of that, and that's where, that's why we have, ecosystem ecologists in my department working on these problems.
So I have a last round of questions, so I would like an answer from each of you. It's a complicated question, so I'll go slowly, so you have time to think. I would like, which will be your view 20 years from now? How would the world of civil engineering education look like? And this is part one, relatively easy, because you are also decision makers. Part two is then to arrive at that vision, which will be the key decision today? What should be done right now, just now, if you want to reach that point? So you can start in whichever way you prefer.
20 years from now seems a long way, but my son is 20 years, he was born yesterday, so it's not so far. It's not so far. For me, one important thing is just we need to change the university system, at least in Spain. Just not to close box. We need to have more flexibility, interrelationship, to have open curricula, just to, at least in Spain, we have very close curricula for civil engineering, and it's very difficult to work with another university, but even with other degrees or other schools or faculties in the same university. So we need to break this. And this is the starting point, in my opinion. And just to select the best educators or the best in the different fields. And what is happening, how I see the university or the education or the system in 20 years, I don't want to say like it's now, because now it's like not like 20 years ago, it's like 100 or 50, at least 50 years ago in the Civil Engineering School of Barcelona, that we are 50 years old. So I want to see something more open, but also more, how to say, I don't want people coming to my school to have a diploma. I want the people coming to my school, it's in my school, to have the knowledge they need to work. And no, most of us, talking of society, are more worried about the diploma than about the knowledge. And what we need is the knowledge, not the diploma. So this is what I want to, for in 20 years.
You live in the future, so
I think
this question is very easy.
This is something very much on our mind. That's why we've been innovating in our curriculum. As I mentioned to José Miguel earlier, we've created a new degree on climate system science and engineering. We keep innovating. Curricula should be a living, breathing, changing, evolving document or set of documents, and it can't be static. It has to be dynamic, and I think we're going through an inflection point in academia, where I believe the very useful model from mid-19th century German academia that served us well for 175 years, but I think it's time for a change. We clearly see that the societal problems that we would like to solve, they don't lend themselves into that way of cutting the pie anymore. It's, the way we say, okay, here's science, here's engineering, this is electrical engineering, chemical engineering, mechanical engineering, civil, environmental engineering, mining, material science and engineering. So things are cross-cutting, And so the biggest challenge for universities is how to negotiate that. So at MIT, we've sort of innovated on interdisciplinary research for a very long time. So our research is very interdisciplinary. Education, up to now, for good reasons, because you want discipline, gives you culture, gives you an anchoring point, gives you a community, gives you standards. So it's very important. But in certain problems, you also want more flexibility. And climate, if you think about big societal problems, political polarization, climate change, transportation gridlock, urbanization. These are things that are very, very transdisciplinary, that cross multiple things. And you need a different way of slicing the pie, so to speak. So that would be my vision for the next 20 years.
Well, my vision, I see in 20 years, civil engineering as the most attractive engineering programs, clearly, because we are dealing with the most important challenges probably of society in the next 20, 30 years, and they need us. But at the same time, I have to say that I cannot imagine what the curriculum will be. I think it will be quite different from the one that we have today. And the name civil infrastructure, the meaning of that name, probably it will be also quite different from the ones that we have today, from what we have in mind today. To arrive there, I think it's not very complicated, in my opinion. We need to answer what the society needs. And I was some months ago in China in a meeting of different directors of schools of civil engineering, and we were very optimistic about the future, about the talent attraction in civil engineering. Things are improving, but my message there is mostly a call for humility. We need to answer, because we are required to answer to the society. What happened some months ago in Valencia, or what is happening right now in California, is overwhelming. It's incredible. It's unacceptable. Okay, and we need. I think this is not about which university is better.
No.
Okay, or even which educational model is better. All of them are interesting. Our 3 universities have different models, and all of them. We need our engineers, and we need to develop more engineers in the future. It's about the society that needs more civil engineers than ever, probably. And we should answer that society. If we answer, we will become probably the most attractive engineering field in the future, because we have the ingredients to be there.
So, Esther, Ali, José Miguel, I think it has been an illuminating discussion. So thanks so much for your contributions and welcome.
Thank you.
Thank you very much. Thank you very much.
Inviting us.
Great to have you here.
Great pleasure to be with you.
Thank you.